Ladies and gentlemen, thank you for joining us today. On behalf of Green Builder Media and Momentive Specialty Chemical, it is my pleasure to welcome you to today's webinar, Working with the Grain, Wood Resources and Chemistry. Our featured speaker is Mr. Mark Alness, Vice President of the North American Forest Products Group for Momentive Specialty Chemicals, Incorporated. Mark holds a BS degree in Forest Product Engineering from the University of Minnesota School of Forestry. He spent over 30 years of his professional career at Momentive and its predecessor companies and has worked in technical service sales and senior management. Sharing commentary today, we have Mr. Ron Jones, President and Founder of Green Builder Media. My name is Butch Gaudette, and I am pleased to function as your facilitator for today's session. I hope that during the course of today's presentation that you will submit questions. I will review the questions and pose them to our speakers during the Q&A time set aside near the end of the webcast. We'll do our best to answer everyone's questions. However, if we cannot get to all of them, we'll send you an individual email with an answer. And at the end of a presentation, we will have an email address where you can submit added questions. So let's begin. Ron Jones, please take a few minutes to position today's discussion, and let's get started.
Thank you so much, Butch. This is a really exciting topic for me, and one that I think is extremely important. As I was doing research to prepare for this, I came across a really interesting article that was part of the September issue of The Economist in 2010. And I'd like to share a little bit of that with you because I think it does a beautiful job of setting the stage for this discussion. For at least 10,000 years since the Ice Age retreated and forests took back the earth, people have destroyed them. In medieval Europe, an exploding population and hard-working monks put paid to perhaps half its temperate oak and beech woods, mostly, as is usually the case, to clear the space for crops. Some 100 million hectares of America's forest went in the 19th century, and an arboreal slaughter similarly reinforced by a belief in the godliness of thus improving the land. Clearing forests may enrich those who are doing it, but over the long run, it impoverishes the planet as a whole. Without a series of effort to solve the problem, the risk from climate change will be vastly increased, and the planet will lose one of its most valuable and beautiful assets. That would be a tragedy. And I wanted to share that as an introduction to the fact that our discussion today is going to center around how we can make absolute most efficient use of our precious wood resources. And we have one of the foremost authorities in that area in Mark Alness. I'd like to start by simply asking a couple of questions, and I have a couple that I'll ask together, Mark, and then give you a chance to provide an answer. The first one is, why is it important for us to talk about this? Why is it a webinar that people would be interested in? And to people in the industry, why is wood so important?
Well, just to give it, you've mentioned the fact that I've been in this industry over 30 years, and the actual fact is why I got into it, is why I think this whole discussion about wood and the resource is so important. I actually saw the inherent greenness of it years ago, and I'm as enthusiastic and passionate about this business that I run and the industry that we serve, the forest products industry, as I was 35 years ago. But it's becoming ever more important, I think, to human beings on this planet to figure out ways of using the best possible raw materials. Everyone that's producing anything these days is going around trying to flog the greenness of their product. The reason I think it is this subject of wood merits a webinar is, in my opinion, the forest products industry and the wood products that it produces are the greenest products that human beings build with. I think this is a story that needs to be told, and the alternatives, whether it's steel, concrete, bamboo, straw, you name it, there is nothing that has a green story associated with it like wood, and I hope to be able to share some of my thoughts and ideas about that today.
What do you think the biggest misconceptions are between chemicals and wood products in the minds of people who are in the industry and in the sustainability arena?
Well, it has to do with the fact that you have a natural product like wood and done with just about everything else we touch. We figure out ways of using science and engineering to actually make better use of those products. And if you look at this industry in particular, it is about, and if you'd go to the next slide, it actually gives a visual representation of what I'm going to tell you about. Just waiting to see if the next slide pops up. And essentially what this story is about is, if you go back 50, 60 years ago, when solid wood or lumber was pretty much what was used in building homes and shelter and furniture, during those days, probably about 40% of that wood was considered waste. It was sawdust, shavings. There was huge teepee burners that were used to burn it. It was composted. It was landfilled. But essentially it was wasted. But through the evolution of this industry and our part in that, through engineering and using the best available resin technology, and what we produce is resins, glues, adhesives, ways of taking smaller pieces of wood and putting them back together through engineering. But what we've been able to do is, today, if you look at that tree that you're looking at, virtually 95 to 100% of the tree is used. Bark and waste is used for energy to power the plants that produce these panel and engineered products. Sawdust and shavings are used to produce particle board and MDF, and in that particular area, our technology was an enabler and able to create these new products that go into furniture, molding, millwork, but essentially it is all used. In addition to that, if you look at some of the new products that have been around for the last 20, 25, 30 years, such as oriented strand board, which now is used in about 80% of sheathing and roofing applications in new homes, it all comes from a wood resource. In this case, it was aspen, which is located in the boreal forest, northern forest areas of North America. And there was an age class of aspen that was somewhere around 35 to 40 years old, and aspen in those areas grows to be 65, and within 5-10 years, virtually 100% of it dies and rots. And there was a huge resource that was underutilized, and OSB was the product that was developed that could utilize it. Today, OSB is spread across North America, and the wood resource in the south is primarily based on plantation stock, which has a rotation of around 15 years. And those trees that are left after it's thinned end up being used in plywood, LVL. But the whole story is about making better use of the timber and pressure on old growth timber, which was obvious over the last 30 years. This is the way the industry responded about making better, more engineered products out of less wood and out of wood that could be managed in a more sustainable way. The other part of this story that I wanted to share today is where chemistry and wood come together, there are trade-offs. And some of the chemistry, there's emissions that are involved that are concerning to people. And one of the biggest technological transformations in this industry's history has just happened in the last couple of years. And that is the transition to meet the new requirements of CARB Phase 2, which is an formaldehyde emission law that was passed in the U.S. And all producers as of January 1st this year now have to meet that CARB Phase 2 emission level, which really takes the formaldehyde emissions down to essentially the background level in the environment. And I think one of the things that really drives me and why we like being associated with wood is the fact that it is 100% solar powered, it's 100% recyclable, it's 100% renewable if we choose to do that. And there's very few other products that can say that.
What do you see on the horizon, Mark, as the next generation of chemical ingredients that might provide us with binders to make them even better in the future?
Well, what we've seen just in the last 2 years, and this transition that I talked about, the CARB Phase 2 transition, was a tremendous amount of work for this industry. The industry, the forest products industry, and Momentive Specialty Chemicals and our piece in that, we supported this regulation. It was technologically doable, and we've taken the emission levels of these composite products, whether it's particle board, MDF, to levels very near background, but I see that evolution continues as the science and engineering develops. We will continue to push for lower emission levels. The key is they have to be able to perform. But I see a couple of things that will drive that. Momentive Specialty Chemicals believes very strongly in green chemistry, which is essentially continually evolving, improving our products so they emit lower emissions. They can be produced in shorter and shorter cycles, which saves energy. But I think we will see, and I expect to see, increased use of bio-based raw materials where they're practical, cost-effective, and improve or maintain the performance of our products. We're already doing that as a company at Momentive. I see the potential to move the UF technology that's used in particle board and MDF, where we now reach obviously the CARB phase 2 levels, and I think Momentive was a leader in that. But I see the potential to move to, over the course of the next few years, in some cases ULIF levels, which is a ULIF stands for ultra low emitting formaldehyde levels, which are basically, getting to that background level of formaldehyde that exists in the environment. The other opportunity I see that will develop where it's appropriate is a no added formaldehyde category. We are working on options around that technology. And as far as the ULIF piece, we actually already have technology that's used in the hardwood plywood industry that actually has reached those types of levels.
You have another image that will help to illustrate some of this, do you not?
Next slide, please. I mean, one of the other things, and I'm just going to talk a couple minutes because there's some topics that I really want to touch on. If you look at the globe right now, there's about 6.2 billion people, and that's going to go to 11 billion people over the next 40 to 50 years. They're going to need shelter and furnishing, and I think that wood will play a huge part of taking care of that. It's one of those raw materials that we literally can manage and grow, and there's really no other building raw material that can say that. When you look at all the possible building materials from a carbon footprint standpoint, from an embodied energy, life cycle analysis, engineered wood and composites, and the resin technology that's needed to make them, have a very compelling story. And for those that are interested in, they can send emails and we'll respond. There's a quorum study that's been done across the globe on the forest products industry and also the resin industry that supports it. But when I think about examples of what this industry has done, if you think about the cars we drive today, they're lighter yet stronger, and ironically, a lot of them have a little green leaf on the fender claiming, their greenness. In fact, engineered woods today and the products we make from them are lighter and stronger, but literally the raw material source it comes from has leaves. And there's a story buried in that. A really good example of how we can use these building products more efficiently is an I-beam. And it literally is made up of a web and a flange, and the flange is made of OSB or plywood. The web is solid wood or LVL, and it replaces a 2x6, a 2x10, a 2x12, and literally uses a third less wood. The slide you have in front of you is the other part of the story about wood and why I think it is the greenest material we use. And it's all about carbon. The issue that Ron mentioned about global warming, which is something we hear about every day, what will we do about it? Well, we have to find shelter for the people that live on this planet and that will come. And there's a huge demand for that, so we have choices about what products we use. If you look at this slide, this was done in Minneapolis, a typical home, wood frame home. It's measured in metric tons. The carbon emissions during manufacturing, use, and demolition for a wood frame house were 434 tons. For steel, it was about the same. The carbon sequestered in wood products was 489 and steel frame 258 tons. The net carbon emissions, because remember, wood is 50% carbon, When a tree grows, it actually absorbs carbon dioxide from the environment. And here in this case, and you could do many, many analyses like this, it's actually absorbing more carbon than the whole process is using. And I think that has huge potential for being part of the solution as we move forward to meet the demands of people and their shelter. And I'd like you to go to the next slide.
Well, we talk about.
And Ron, what I'm trying to show here is
because
it gives you an example of all of or a lot of the very new engineered wood products that have been developed over the last 20 to 30 years. And it shows you the areas where Momentive Specialty Chemical provides adhesives, resins, and products to be able to make those products possible. A couple of the distinct areas that I want to call attention to is there are products that are used in the interior of the house, furniture, moldings, different pieces that are never exposed to the exterior environment, rain, moisture, in construction. And they use interior resins, or what we call urea formaldehyde, which is now transitioned essentially to melamine UF resins because of the CARB phase 2 transition. They also use melamine formaldehyde resin systems. And they're very different from the exterior products that we use because they're not as durable, because they don't have to be. For the exterior products, wall sheathing, LVL, flooring I-beams, all those products use PF, PRF, which is phenol resorcinol formaldehyde products, and they're very, very durable. If you want a pictorial on what they might look like, if you think about the black handles on your pots and pans at home, or items like that, that's phenolic resin. And essentially that type of technology is used for making this. Why are these technologies chosen, UFs for interior and PFs for exterior? It's because they're low cost, efficient, productive, and safe, and they're available in mass quantities to meet the needs of this industry. One of the other things that's interesting about interior products like particle board and MDF stands for medium density fiberboard, is most of those products, when they're actually finally used in the home, they are either coated with a fine veneer or an overlay of melamine or an overlay of some substrate to give them performance characteristics that people look for in homes. They also allow us to make very low cost furniture products so that they're accessible to everybody. But it's the combination of the wood engineering and Momentive resin technology that's made these products possible.
Mark, can you talk a little bit about the difference between the chemistry that we find in those interior products and the ones that we find in the structural components?
Yeah, and if you could go to the next slide, it'll give a little example as I talk about it. The slide that you're looking at basically is comparing the emission levels of solid wood, and wood gives off formaldehyde naturally. And the interesting thing, and one of the differences between interior and exterior resin systems is the level of emissions that are associated with them. But formaldehyde is one of the key components of all these resin systems. They're reactive. They allow us to make these polymers. But the thing about formaldehyde is it's ubiquitous in our environment. Literally, our human bodies produce it, all animals produce it, all plants, trees, any form of combustion. It's something that's everywhere in our environment, and it's received an awful lot of attention. That has been specifically focused around UF resins that are used in interior products. And that is the area where the industry has focused to reach these new CARB phase 2 emission levels. The exterior resin systems, phenol formaldehyde, phenol resorcinol products, are much, much lower emitting formaldehyde just based on the fact of the technology that's used to make them. And essentially they're at the same levels, background levels of what wood is. And that's why they're not covered under the CARB phase 2 emission levels. But if you look at this chart, you can see if you take the top right bar chart, the purple bar represents a example of formaldehyde levels in solid wood. And if you look immediately to the left, there's 3 bar charts for carb phase 2, and it's MDF particle board. And it shows you that they're very, very close to the background level that is emitted from wood itself and actually the environment. If you go into a major city on a hot summer day, the formaldehyde emissions in that environment could very well be as high as any of these bar charts. That was the goal of the industry, and I think we're very, very close, and we'll continue to improve on it. But it tells the story, and that has been the focus around this the formaldehyde issue. One of the things that I'm most proud of working for Momentive Specialty Chemicals is the challenge over the last 20 years has been to reduce the emission levels of these technologies, but at the same time maintain their performance. And if you look at the bar chart, where back in the 80s, we were at 0.3 parts per million formaldehyde, and we've taken it down, basically to background level. And the performance in the industry, it's a lot of hard work, a lot of technology, but essentially we've been able to maintain that type of performance.
Mark, in previous conversations that we've had, I've expressed to you that the second most important concern on behalf of the folks that we survey from the consumer side of looking at the built environment, homeowners and apartment dwellers and everyone who's involved in occupancy, second only to energy concerns is indoor environment quality. And of course, the air quality is of concern to building scientists and everybody that's in the industry. And as I pointed out in our conversations candidly before, when most people think of formaldehyde, they think of specimens in jars, frankly, and science experiments. Where do you see the story of that chemical going? Where do you see the chemistry going? And how is Momentive specifically addressing those concerns in terms of their messaging and providing information on the direction?
Well, and your point about the indoor air quality is becoming more and more important. One of the key drivers of that is as we learn how to engineer these materials and make homes more efficient. I think the houses we build today are the best that have ever been built. They're stronger. They use less material for the square foot. They're more efficient. And what that essentially does is it closes up the home environment. And so the use of air-to-air heat exchanges and just understanding how you need to exchange air, but literally everything in that house contributes. When it comes to formaldehyde, it's a natural occurring product. So the plants you have growing in your house, the natural gas stove that you have, that's combustion, it's a source of formaldehyde. But essentially, if we get to the background levels that are natural in the environment, I think it's a issue that can be resolved. And I think it's amazing the outcomes that this industry, through science and engineering, has been able to produce the products that we use today. And I hope that we have the good sense to actually look at the science. Formaldehyde in particular is probably one of the most studied organic chemicals known to man. It is also one of those rare ones that we can use actively to produce products, to make these wood products possible. But at the same time, it's produced by our bodies. It's produced by the environment. Human systems are used to it over thousands of years. It's something that is part of our environment. And I just hope that we have the good sense to actually look at the science and understand the real health effects, because I think the story is compelling. These products are safe. And one of the things that we've tried to do for a number of years is get the National Academy of Sciences to actually look at the research, both the health and the products themselves, and actually do a peer review and tell the story from their perspective of what the health effect is. And in March 2011, this year, within a month, a committee of the prestigious National Academy of Sciences will issue its peer review report of EPA's draft Integrated Risk Information System assessment on formaldehyde. This is anticipated to be a scientific milestone in the ongoing evaluation of formaldehyde risk. It is expected that the committee will have considered the full weight of the scientific evidence available, and this is a key difference from where the EPA has been to date, and I think it's what we've been looking for a long time. But whatever the source of emissions, whether it's formaldehyde or some other product, cleaning goods that people use in their homes, it'll be an ongoing issue that the industry will have to deal with. It's no different than if you remember hearing about mold 4 or 5 years ago. It was a huge issue. And I think a lot of it stemmed from the fact that we were making homes tighter, more energy efficient, but the industry missed a few cues on how to manage that moisture in the environment.
I know that you have another image for us as well.
Yeah, next slide, please.
Gentlemen, as we move to the slide, I'll just mention we've been on air for about 26 minutes. So the next 4 or 5 minutes, we would look to be moving to questions and answers. Ladies and gentlemen attending today's webcast, now would be a good time to submit questions. Gentlemen, sorry for the interruption. Please continue.
And I just have a couple more comments, but what this is it's a trademark that Momentive Specialty Chemicals has, and it's our family EcoBind resin technology, and really what it represents is the state-of-the-art in high-performance resin systems with the lowest possible emissions that are available in this technology in the world today, and we're very proud of this. And I think through our EcoBind technology platform, Momentive will continue to lead the way in this continued innovation to help produce engineered wood products that are cost-effective, efficient, productive, safe, and sustainable. And I believe that Momentive will continue to enable the increased use of wood, the greenest product people build with, in my view, in ever more creative, safe, and effective ways. And I'm open for questions.
Very good. We do have questions coming in. The first question has to do with durability, which seems to be a common question. This person is asking, aren't other products more durable?
Is the question referring, are other products more durable versus wood, I assume?
Correct. Yes, that's correct.
Well, yeah, so if you could make something out of cement or aluminum or steel, the potential is, depending on its use and how it's used in the building, it could be more durable. But wood is a material that's been around for thousands of years. Since humans crawled out of caves, they figured out, because it's so efficient, available, and if you engineer and design a wood structure, they can last, hundreds of years, depending on, how it's actually designed. And I think the trade-off is, here you have a material that sequesters carbon, so it's part of the solution to this whole global warming issue in its own fundamental way. It's renewable, it's recyclable, and humans can manage this as long as we're on this planet. What other material can you say that for? Cement has, or steel or aluminum, the embodied energy that it takes to use those products, the renewable story about those products is completely in a different category, in my opinion.
Mark, you talked a good bit about formaldehyde, and it was enlightening to listen to your comments about reductions in what everyone, I guess, appears to view as a virulent VOC. And we do have a question from Catherine asking, besides formaldehyde, is Momentive working to reduce VOCs or off-gases, other off-gases from wood products?
Well, if you look at wood itself and you literally burn it in your wood stove, I mean, there are literally hundreds of chemical compounds that come off. In the normal use of wood in a building material, really what naturally comes off of wood is formaldehyde. There's very little other aldehydes or products that are issues. In the manufacture of wood products, where the energy for running the processes is produced by burning some of these woody materials. They have the latest technology for basically destroying these VOCs at the site where the plant's manufactured. These are catalytic oxidizers. And in fact, the plants that we have in North America, we have 19 to 20, well, we actually have 20 plants. Around the globe, we have around 42 to 44, and they're located wherever the trees are. But even in our plants, we focus on absolutely the minimal amount of VOCs that leave our site, and it's no different in the forest products industry.
Thank you. Question for either Ron or Mark. Ron, in your opening comments, you talked about the history of destruction of forest on our globe. The question asked in today's status in the United States or globally, are we still seeing depletion, deforestation, are levels holding, or are we improving our situation in terms of forest lands?
Well, I'll comment and then Ron can.
Well,
I mean, one of the I think misconceptions, and it goes back probably 150 years when the U.S. was settled and the way people managed timber then, there was a lot of dramatic mistakes that were made. And I think to some extent the forest products industry still lives the legacy of that. But if you actually look at the amount of timber that's being grown in North America and around the globe, there's literally a wall of wood coming over the next 20 or 30 years. And it's focused on where we need the wood for a resource to put people in houses and build products with it. We're managing timber in a very different way. A lot of the pressure has been taken off old growth forests for a variety of reasons, but one of the ways we do that is by managing our timber resource very intensely. Now, you could argue, well, I'd rather have everything be old growth timber. Well, if you really want to take the pressure off the wood resource, get rid of all the people, because there's a compromise that has to be made. Ron made a comment about farmland. Probably the farmland and city development and sprawl has probably reduced the amount of timber more than anything in the last 50 years. But if we focus on growing timber as fast as we can, using it in the most sustainable way, developing products like the I-beam I talked about that essentially uses a third less wood than what we used to use to do that task, I think the story on the global timber supply is much, much better than what people really are aware of. And it's because the same techniques that we're using here in North America, where I think we manage our timber extremely well, they're adopting in other areas of the world where the climate conditions are good enough where they can literally grow plantation rotations in 10 years, like in Brazil. And what that's done in Brazil is the pressure and the talk over the years is been around the concern around the Amazon. And by growing plantations in southern Brazil, that's where the wood resource is coming from now, primarily. It's not from the Amazon.
Ron, you had comments, and as you comment on this question, I'll throw an added question in having to do with global demand. It seems like every resource we have is finding its way to China with their phenomenal growth. So as we talk about forest resources, would you roll in any comments you would have, Ron, and Mark, you as well, relative to global distribution, i.e. China?
I'd be happy to. But as a comparison, and Mark mentioned the Amazon basin and Brazil in particular, according to the information that I have, there has been tremendous improvement in some parts of the world in terms of the destruction of what's referred to as the world's lungs, that is the tropical rainforest. In 2004, there were some 2.8 million hectares, or almost 11,000 square miles of the Amazon that were razed. But in 2009, that was reduced to around 750,000 hectares. Now, that's a tremendous increase. It doesn't mean that the problem has been reduced to the level that it needs to be, but it is an important step forward. In what is referred to as the larger, poorer countries, notably China, we have seen where there have been tree planting schemes that have been launched to help prevent deforestation-related environmental disasters because of the fact that, in particular, soil erosion and containing runoff water and securing water supplies depends so heavily on forests. One of the big concerns that we see now is particularly in the Congo, which is second only to the Amazon in terms of the size of the rainforest there, that the clearing for growing crops is continuing to increase at a rapid rate. So what I would have to say is that at this point it's very much a mixed bag. If we can continue to improve the plantation forest ratio, if we can continue to find ways to help mitigate the loss of old growth and the very important stands of trees that we find in different parts of the world relative to population growth, then we're going to have a better chance at continuing to benefit from all of the forest resource. But it's going to take a concerted effort.
Ron, if I could comment?
Certainly.
As you mentioned, the Amazon. I mean, it's the cropland that's driving the deforestation to a great part in that area of the world. I mean, they're clearing the forest to grow crops. It's really not a suitable area for much of that, and it needs to be managed much better. But to the question about China, well, China's driving demand for just about anything you can imagine, or the BRIC countries, all commodity minerals, chemicals, wood products. The history in China of their forests is a very sad story. I mean, they basically cut it off, but in the last 5 to 10 years, they planted an area the size of California with fast growth, plantation type trees because of their tremendous demand for wood products. And we're starting to feel that impact in the last 2 years significantly here in North America, and specific to the western coast of BC and the western US. And it's not for finished wood products as much as it is for raw logs. And it's because of the pressure they've put on Russia and Russia has put on them, where Russia wants to have the Chinese buy finished wood products versus just the raw material. And I suppose this is one of those areas where they can reach out and try to get the wood resource that they need. But I think, to me, it emphasizes this is a product that will continue to have ever and ever increasing demand, but it is a product that we literally can grow and manage. And the collective knowledge about how to do that the most efficient way possible, I think, is spreading across the globe. And hopefully as human beings, we can manage it. But if you're looking at tin or copper or gold or oil, none of that will be recreated. None of it can be grown again. That's why I think this product called wood and the versatility of it, and taking the technology that Momentive Specialty Chemical has to make products that use less of it or use it in a more efficient way from an engineering standpoint, is one of the most important things that we can focus on from a building industry.
Very good, gentlemen. Mark, we have a question submitted by Brian. He's saying, while the use of composite wood products have improved wood utilization, it has also increased the potential risk of loss and property damage in fires. What is the industry doing to increase the safety of composite products when subjected to fire?
That's a great question. And as with any evolution of technology, like making lighter cars that are stronger, just the fact that they're lighter doesn't make them stronger. It's the engineering around how you put them together. And those are the same issues that are faced in building products and wood products. One of the things that we've worked very, very hard on, and I mentioned the I-beam example, but the adhesives that actually glue the web and flange together, for example, are made out of PRF. And it has the highest heat rating of any adhesive that's used for that purpose. And it's to address the very question that I was just asked. Now it's a bigger issue than that, and the industry will continue to work on what are practical fire retardants that can be applied that will minimize the effect, and it's an evolution, but it is something the industry is aware of, and it's one of those trade-offs that we have to, over time, come up with better solutions on how to resolve those issues. But the day of going
Very
back
good. We
to,
have a
but
question.
the day of going back to building houses out of solid lumber, solid roofing, 2x10s, 2x12s, the raw material is not available. With the number of people on this planet, we've got to be more sensible of how we use these products.
Thank you, Mark. We have a question submitted from Beth asking if Momentive's products are grown in forests that are FSC, Forest Stewardship Council approved. Specifically, she wants to know if she can use it contributing to LEED certification for projects.
Well, the products we make are resins and adhesives that are used by the forest products industry to actually, that use the wood to actually manufacture the finished product. So the source or the question basically has to go to them. And we deal with all the major forest products companies in the world, and there's been a huge transformation that people should be excited about. This industry in its total has taken this issue very seriously, and this is about sustainable forestry. I think one of the issues is there's so many different certifications, whether it's FSC or the others, and there's lots of them. It gets very confusing to people, but the essential tenet of all of that is to manage forests in a very sustainable way. And I think we have the full capability of doing that. I think the industry has embraced it. I think you should be very encouraged that most of the wood products you go and buy at a Home Depot or a Lowe's, if you trace that wood back, you will find that it is certified under some format like FSC to certify that it's being managed in the correct way. Is everything perfect? No. But the trend is people have recognized, and the industry has recognized, this has value both to them and to the consumer, and the response has been amazing, I think, over the last 10 to 15 years.
Very good. We have another interesting question. The question is, how effective are new growth forests in sequestering carbon? Right now, carbon sequestration is one of the things we need most to combat the drastic effects of climate change. Presumably, new forest and planted crops can't sequester to this, cannot sequester to the same extent that old growth forest can. Is that true?
Well, I mean, Ron can and probably chime in, but I'm not an expert on the science of carbon sequestration for a plantation versus old growth. But what I think I'm an expert on is the fact that demand for these products and the solutions to be able to come up with the raw materials, when you look at the sum total of the story around this, there are trade-offs. But the fact is, carbon, whether it's in a plantation or an old growth, or trees, wood, is 50% carbon. Now, does it happen faster in a plantation, or the reality is if it's a plantation and it is harvested and it is produced into a wood product that goes into a home that, say, has an average life of 50 years, I think that's conservative, but say it's 50 years. The interesting thing about this wood products, forest products industry is even at the end of that life, our societies are developing systems of taking those buildings apart and recycling that material again. For example, an old house comes down, there are literally plants all over the world now that take that, what they call urban wood waste, grind it up, make it into particle board or MDF, and it ends up being used in new products again. So the carbon is still sequestered. But that whole science is very complicated. But on balance, the compromise is there were no human beings here. There'd be lots of carbon sequestered. There would be a lot of carbon dioxide not produced. The fact is, there's 6.2 billion people going to 11 billion, and there will be compromises. And I think this industry represents one of the best stories. And at the end of the day, trees and wood products will be part of that solution.
Very good. Gentlemen, we're approaching the end of our allocated time. We have time for just one more question, and then perhaps Ron and Mark, you would care to make a closing comment. The question has to do with your comments, Mark, relative to green chemistry, the development of green chemistry. You talked about lower VOCs, shortening the production cycle, which inherently reduces energy, et cetera, used in production. And you talked about bio-based raw materials. The viewer asked if you could expand on what you meant by bio-based raw materials and how they would be applied.
Well, over the last 10 years, we've looked for any and all alternatives because some of the key raw materials we have just frankly are driven by oil or natural gas. They're derivatives of those streams, and they are not renewable. But the fact is, they happen to be the most effective, but they also are very volatile when it comes to pricing. And again, it's driven by global demand. You're watching right now oil prices go up significantly. If the turmoil in the Middle East continues, we could see gasoline in North America at $5 a gallon. Well, that same kind of price pressure is on our key raw materials. So we're motivated not only by finding alternatives that are bio-based that may have a different cost structure, that piece of it, but also what effects they could have on emissions and performance and this whole green chemistry concept and sustainability strategy that we have as a company. And we literally are and have been using products. One of the issues that are bio-based, the issue we have is the availability in the quantities that really make a difference where we need them. That industry will continue to develop, and the searching for those technology options and opportunities, we are all over, and I know the industry is looking at it, but it is something that we're very, very interested in. We're doing it now, and for example, I mean, you have industries like biodiesel and ethanol, and these are all bio-based products. Are there derivatives of their manufacture that can be used somehow in some of our technology? Those are the areas that we continue to look at no matter where they are.
Well, gentlemen, I want to thank you for your participation today. Ron, if you might have a quick closing comment, and Mark, if you would follow him with the same. And at the close, Mark, if you could perhaps provide an email. I thought we had a slide, but I guess we don't. That any questions that were not asked could be submitted. So Ron, if you would care to start, and we'll just take a minute or two and then we'll close today's session.
Thank you, Butch. I'd be happy to, and I do want to thank Mark for joining us today and providing this information. You know, the question was asked about the comparison between plantation trees and an old growth forest. And at the end of the day, we have to appreciate that in our lifetimes, and indeed in several coming generations, we would not be able to realize the replacement of the old growth forests that we've lost over the past few centuries. Losing the Amazon rainforest as an example could reduce rainfall across the entire area of the Americas, and potentially the dire consequences for farmers as far away as Texas. By regulating runoff, trees help guarantee water supplies and prevent natural disasters like landslides and floods. Losing the rainforest would mean losing millions of species. Forests contain 80% of terrestrial biodiversity, and for those concerned about probable effects of climate change, forests contain twice as much carbon as the atmosphere in plant matter and soils they cover, and when they are raised and the soils are disturbed, most of it is emitted. So if the Amazon, as an example, went up in smoke, a scenario with a bit more clearance and a bit more warming makes conceivable, it would spew out more than a decade's worth of current fossil fuel emissions. That's why it's so important for us to have a handle on the necessity of engineered wood product and the chemistry that relates to that. And so I'm going to leave it to Mark to wrap up, but I think that I had asked in the beginning of the webinar why this is important. I think it's been illustrated.
Thank you, Ron. And Mark, as you go to your closing comments, I'm advised that the EcoBind website, and you see the EcoBind logo on your screen, ladies and gentlemen. The Ecobine website has a Contact Us portion on the site. So anyone who either did not get their question answered today or wishes to submit an added question can do so on that website. Mark, your closing comments?
As a representative of Momentive Specialty Chemicals, you know, it's not a normal connection that people have to wood products, but hopefully you have a better understanding of the piece and the part that we play in this continuing evolution of using these products smarter and more sensibly and using them more efficiently. We hope that our EcoBind family of technology will continue to enable, like I said before, the increased use of wood. I believe it is the greenest product that people build with. I don't think it's something that's been recognized by people as much as it should be. To the points that Ron brought up about the pressure that's on all these resources, the pressure is not going to go away, but the demand for products people have to use isn't going to go away either. And when you have a raw material that's literally powered by 100% solar, it's 100% recyclable, it's renewable, it can be managed. There are no other options from building materials that I can think of that meet that requirement. It has to be managed, but I think we're capable of doing that. We look forward to Momentive's part in the continuing evolution of this technology.
Very good, Mark, and thank you. Ladies and gentlemen, on behalf of Green Builder Media and Momentive Specialty Chemical, I thank you for attending today's webcast. I know it was informative. It was informative for me, and I hope as for you as well. Thank you, and look for future webinars from Green Builder Media and its partners. Have a great day.